So the purpose of this video is to go through creating a Matlab function file that will give us the arctangent of the sine and cos that we input to this function that can accurately determine which quarter in the trig circle we are in. The reason I'm making this video is that if you use Matlab or any other mathematical programs and you use their arctangent commands, for example in Matlab you have A10 or A10-2, they give you the angle in first and fourth quarter or first and second quarter. So they won't give you the accurate quarter in which this angle actually exists. So we're going to use GNU Octave, which is an open source program that mimics Matlab, and create a function file that complements the A10 command in Matlab or A10-2 command in Matlab, and eventually it gives us the angle in the correct quarter in the trig circle. So I'm going to write a function file. For that I have to start with the keyword function, and the output I'm going to call result. Let's make sure that I don't make any typos. And the function name that I'm going to be calling in my command window is going to be arctan. This is what we define. And then let's input to this function two variables, x for cosine and y for sine. So basically we're defining in the first keyword that this file that we're creating is going to be a function file. Result is where the output is going to be saved. Arctan is the command that the end user will call to run this function, and then x and y are the two inputs to this function. X is going to correspond to the cosine of my angle, and y is going to be corresponding to the sine of my angle. If I click enter, there is a end function keyword automatically created so that I won't miss putting that in my function file. The first thing I want to do is to check if the input to my function file has been both zeros and show an error to the user and abort running this function file. So I'm going to say if x is double equal 0 and double appearance for and y is equal to 0. So basically if x is equal to 0 and y is equal to 0, meaning that the user has input arctan 0 dash or 0 comma 0, we're going to show an error message. Both inputs cannot be 0. When this happens, and we'll try it when we go into running the code, and if I input 0 0 for my arctan command, Matlab, or in this case GNU Octave, will show this error message and abort running the rest of the function. Next, what I want to do is to call result and find arctangent of this angle in the first quarter, regardless of the sine of x and y, or in other words, the sine of x and y. I'm going to say find the arctangent of ABS y, absolute value of y, and then the absolute value of x. So this will give me the angle in the first quarter. Now I have to write a series of if conditions to see whether I am in the first quarter or I'm going to be in the second, third, or fourth quarters of my trig circle, and then adjust my result accordingly. So if I'm in the second quarter, sine is going to be still positive, but cos or cosine of my angle is going to be negative. So I put an f here, and I'm saying if x is negative, which means if cosine is negative, but y, which is the sine of my angle, is positive, meaning that I am in the second quarter, add to the result. So result is going to be edited by pi over 2 radians. So add 90 degrees to first quarter, which is what we defined in line 6 over here. So this takes care of the angle if it's in the second quarter. But what if we're in the third quarter? So else if I'm in the third quarter, in this case, both sine and cos are going to be negative. But in order to make sure that the pi over 2 and pi and 3 over pi, or 3 pi over 2 also taken into account, I'm going to say if x is less than or equal to 0 and y is also less than or equal to 0. This seems to be contradicting what we wrote over here in line 2 to line 4, which means if both x and y are 0, show an error message and abort the function. But here I'm checking for whether both x and y are 0 or not. The first thing we need to consider is that if both x and y are 0, this error message is shown and the remainder of the function file is aborted. So the user will not, or the function will not get to line 10 whatsoever. But I'm using these equal signs here because the trick in this function is to make sure that the border lines, these 90, 180, and 270 degrees, or pi over 2, pi, and 3 pi over 2 are also taken into account or considered in my function file. So that's why I'm using both of these, knowing that this will not happen when both are equal to 0. Anyway, so with that, let me just put this here, that this is corresponding to third quarter. And I'm going to say when this happens, result is equal to result plus 3 times pi over 2. It means add 270 or 100. Actually, no, in this case I have to put pi over 2. Sorry. So I'm going to add 180 degrees to first quarter. So first, second, and third quarters are taken care of. Now I have to do the same thing for the fourth quarter, which means I have to say else if. In this case, if x is positive, which means cosine in this case is positive, and sine, which is y, is negative in the fourth quarter. So this is fourth quarter. Add to the result 3 times pi over 2. Or in terms of text, add 270 degrees to first quarter. And that is the end. This is a function that will take care of the correct quarter in the trig circle when we write a function file, or when we want to find an arctangle of a given value. So let's save this. And because this is going to be a function file, let's call it arctan.m. Don't change this. Save it, and this arctan.m is created in my working directory. Now let's try the function file that we created with some commands. If I say arctan, and if I put 0 and 0 for it, I expect to see an error message, and the rest of the file should be aborted. And exactly what I expected happened. So both inputs cannot be 0. Now let's try the border lines when we want to make sure that the 0, pi over 2, and 3 pi over 2 are also taken care of. For 0, sine should be positive. Sine should be 0, which is y, but cos should be 1. If I put that, so the answer is 0. For pi over 2, cos is 0, sine is 1. So if I put this, I get 1.5708, which if I do pi over 2 here, that's the same thing. Then when we go into the third quarter, for pi over 2, or pi, 180 degrees, cos is going to be, or sine is going, cos is going to be minus 1, and sine is going to be 0, which did not happen in this case. Something is not functioning. Okay, that's over here because I added pi over 2. So let me save this and come back here and rewrite my command. Okay, it worked. I don't know how I missed this, that I put pi over 2 here. Anyway, so that's taken care of. And then let's go to the third the third borderline angle, which is 270 degrees. In this case, sine is going to be 0. or sine is going to be -1 and cos is going to be 0. And if I do 3 times pi over 2, I get the same angle. So these are the borderline angles. What happens if I give other angles in the middle? So let's do arctan of 1 and 1. So I'm expecting to get 45 degrees. And before that, let's see what pi over 4 means or looks like. Pi over 4 is 0.0854. And then if I do arctan of 1 and 1, I'm expecting to get the same result, which is that. Now let's go to the second quarter. In the second quarter, cos is going to be negative, which is the first input to my function file. Gives me that. So let's see what happens if I add, or if I do the rad to degree of my answer. That's 135 degrees, which is exactly what we expect to get in the second quarter. Now go to this third quarter. Both of them are going to be negative. So let's again verify that this is the correct angle. 225, which is 180 plus 45, which is the third quarter. And finally, in the fourth quarter, cos is going to be positive and sine is going to be negative. And again, rad to degree of answer, that gives me 315, which if I say 360 minus 315, that's exactly 45 degrees in the negative direction. So there you have it. We created a very small function file that can give us the correct angle in terms of the quarter and the trig circle when we give the inputs for the sine and cos of our angle.